All right, welcome back to AP Statistics. This is Dr. Kling, still not affiliated with the College Board. Just want to make that clear. Today's topic is scatterplots. Okay, and let me show you a whole bunch of scatterplots, and we'll come back to these in a little bit. This is all taken off Google's images, just searching for scatterplot examples, and again, I'll come back to that. So scatterplots have quantitative data, so maybe I'll write that down, quantitative data, and we look at two variables. If we think there's some causality involved, we put the explanatory variable on the x-axis, explanatory, I have no idea how to spell that, on the x-axis, and the response variable on the y-axis. And then we have a bunch of data for each thing. So for example, in this sketch, I have on the y-axis, the variable I'm trying to explain is the 4th grade math proficiency percent in a school. So you have a school, you test all of the kids, and you say, were 30% of them, the 4th graders, proficient in math, and there's some definition of proficiency. Or we're 40%, we're 50%, we're 60%. What percent of the 4th grade math students, what percent, that's a percent sign, what percent were proficient in that school? So that's my y variable in this graph. And the x variable is a measure of poverty. And poverty, so the percent in poverty, again that's a percent sign, as measured by the percent on what's called free and reduced meals, and that's what FARMS stands for. And they actually use the acronym FARMS around here to stand for free and reduced meals. So if your income is such that the student is eligible for a free and or reduced meal at lunch, that's an indicator of poverty, and the schools around here keep statistics about how many farms, what percentage of their students are farm students. So what a point like this would indicate is that there was a school with a very low percentage of farm students and let's say 10%, and a relatively high percentage scoring proficient in math, 70%. And this would be a school where there was a relatively high percentage of students in poverty, let's say 70%, and a relatively low percent proficient in math, 40%. And I think the data in our state are that there is a rough downward slope. It's not perfect, but there's a general downward relationship. That is, the schools where there's the most poverty tend to have the lower percentage of students passing 4th grade math proficiency. So that's the sort of information you can get out of a scatter plot. And let me show you another sketch. This is with the same variable on the y-axis, the percent of students scoring proficient in 4th grade math test. And this is the dollars spent per student in that school. Or maybe I think in the school district. This might be school districts. So there you might expect to see some positive relationship, that there's the school districts that spend more have a greater percentage of proficiency. And if nothing else, you might think that that would be negatively related to poverty, but in fact there's my sense when I looked at this data a few years ago is there wasn't much of a relationship. It was just kind of scattered around. You just had Montgomery County sitting over here with a much higher expenditure amount per student, but it was very much average in terms of the proficiency scores for the fourth grade students, and that was actually kind of controversial, which is why I looked into it. Okay, so some of the things to look for in a scatter plot then is if you drew a line of best fit, would it slope up or down? And if it's up, we say that the relationship is positive between the two variables. And if it's down, we say it's negative. And if we can't tell, we say no relationship. So in this first one, it seems roughly that if you drew a line of best fit, it would slope down. It might be something like, I don't know, something like this. And here, the line, there is no clear line of best fit. So in the top one, it would probably be negative, and the other one, it's hard to tell. So you can ask about that. The next question you can ask is how good a fit. And basically, if the points are close to the line, and we'll show what we mean in a minute. If close to the line, then we say it's a good fit. If they're far from the line, then we say it's a poor fit. Okay, another question we can ask is the relationship linear or nonlinear? Linear, the points would kind of look like they fall on a line. Nonlinear, points might look like they fall on a curve. Okay, then we have a couple other questions which I probably won't be able to give examples of, so I'll postpone those for a second, and let's just look at some of these examples and just walk through them. Okay, so this one is the relationship positive or negative. I would say it's positive. The fit isn't perfect though, because there are a lot of points that wouldn't fall right on a line. It might even be a little bit nonlinear in that it seems to be just a tad bit concave. It's kind of tailing off here, so it might not be linear. Okay, this one, positive and a very strong fit, and it seems to be very linear because all the points lie close to the line. And actually, this one illustrates one of the other questions, which is, are there outliers? Are there points that are way off the line? And these 2 points here would be outliers. They're way off the line. And this one here illustrates the other question, which is, are there influential points? And that's a point where it's way over on the x-axis. You see this point? It's way, way over to the left on the x-axis compared to all the other points. What that means is that this point is going to influence the slope of the line. In this particular case, it pretty much lies along the line given by the other points. But if this point happened to be up higher, it would really flatten out the curve. And if it were down lower, it would really steepen the line. And so that's a potentially very influential point. Okay, this is an example that I guess they call perfect positive correlation because the points exactly line up on a line. Here's an example of a negative relationship because the points, everything slopes downward. Note also that we have some very influential points over here. That is, these are points that are way far away from the main body on the x-axis. So they have a lot of influence. If these points happen to be up here, the downward slope would not be nearly as pronounced. This one, wow, this one that looks like with points all over the place, it's hard to even tell which way the line would slope, so it's not there's no clear direction there. By the way, I'm not even looking at what's on the axes on these graphs. That's what I drew the ones on my blackboard for, to show you that. Okay, here's something that looks like it's generally upward sloping. Not clear what to do with points like this. Those would be, if you drew the line of best fit, those would probably just remain as outliers. This point, because it's way over to the right, is influential enough it might pull the line up a little bit, but there's so many other points it might not, the influence wouldn't be too dramatic. Let me make sure that that's in the line of vision. Hang on. I'm going to do this. Okay, you may just have to look at it without me highlighting it. It's like this graph here. The upper right point could potentially move the line up a little bit, but these 2 points that are up here would certainly be outliers, and this would be an example of not a good fit because points wouldn't lie on the line. Here's a downward one where the fit is moderate. The points generally lie on a line, but there's some discrepancies relative to a line. Here's something, well, we can actually see what's on the axes: years of experience and income. So the more experienced you are, the more income you have. Doesn't look like a perfectly linear relationship. It seems to tail off. You get a big increment from experience kind of early on in your life as you get from 10 to 20 years. From 20 up to 35, not so much. So that would be an example of nonlinear. Okay, so let me write down these 2 other questions. One was influential points, and those are extreme values of the x variable. And the next one was outliers, which are values of the y variable that are far from the line. So let's just review the questions that we want to focus on. Does the line of best fit slope up or down? And if it's up, we say there's a positive relationship, down a negative relationship. How good a fit? And that's based on how closely the points cluster to the line of best fit. If they all lie pretty close to it, it's a very good fit. If a lot of points are far from the line, then it's a poor fit. Linear or nonlinear? Are there influential points, and are there outliers? And that's it for our introduction to scatterplots.